what you're looking at there's a sheet of aluminium, and we have an antenna base mounted through the middle of it. So this is a Marconi antenna. We've got a counterpoise or ground plane underneath here, and we've got a quarter wave whip. Now if you want to know what a Marconi antenna is, have a look at my video back catalogue. We're going to experiment with this antenna today. We know that this antenna has a requirement for this counterpoise to be both conductive and reflective, because we end up with an image of this antenna here below the counterpoise. And we also know from our theory that there's a current maxima at the base, current minima at the tip, and we have a voltage minima at the base and a voltage maxima at the tip. And what we're going to do with this antenna is we're going to support it well above ground. At the moment it's just sitting on the grass on my back lawn. We're going to support this well above ground. I'm going to support it on a sheet of core flute actually. I'll show you that arrangement in a minute. The whole idea is that's an insulator, and we're going to support it well above ground to get it away from any ground influence. And we're going to move this mounting point progressively towards the edge. We'll also probably jack it up to attempt to simulate having this antenna mounted completely without a ground plane. Now we're going to look at all of this. We're going to do some measurements, some VSWR measurements, and we're going to do that with Anritsu Sitemaster. And we're going to consult some charts. Now I've got my instruction manual for my Bird Model 43 here, and in the back of this we've got VSWR ratios, and there is another chart in this manual which gives us a percentage of reflected power based on VSWR. I will organise, there it is, I will organise to scan these charts and attach them to this video. What we're attempting to do here is to get an idea of what the VSWR is and how that will have an adverse effect on the antenna performance. Of course, if you've got an antenna, again, have a look at some of my other videos where we talk about radio as a system. If you've got an antenna here at this end and we're transmitting to an antenna at the other end, you want the performance of this to be as good as you can get it. Now here's my test setup. I have here a sheet of core flute. It's got a triangle formed on one side. This was a display stand. It was originally a shop display, and we're just going to utilize it to get it well away from ground, or as far away from ground as I can possibly organize. And at the moment what we've got is we've got this thing on the end of the arm of the washing line, and what we're going to do is we're going to mount our aerial up in here. Look from below, you can see there's the end of the washing line, so we're actually going to mount this antenna up here somewhere. And the core flute effectively provides us with no ground plane, but provides us with a form of support. And we'll just see what sort of measurements we get and see if we can draw some conclusions from what we're doing. Okay, here's our first test. We've got our quarter wave mounted above our counterpoise in the middle of the sheet, and we're going to have a look at what the Anritsu tells us. hopefully this can be seen. So we've got a VSWR of 1 at the bottom and 3 at the top, and we've got a frequency of 140 megahertz here and on the left hand side, and 160 megahertz here on the right hand side. Now right where the marker is in the middle, we've got a VSWR of 1 to 1.22 at 149.92 megahertz. So that's a fairly good VSWR. It's much less than 2, in fact it's much less than 1 to 1.5. So I would consider that to be a very good aerial for the purposes of a radio system. Anyway, that's step 1. So we've got a VSWR 1 at the bottom on the left hand side, 2 at the top. We're sweeping between 140 and 160 megahertz. So we've got a nice dip, right about 150 megahertz. Now this Sightmaster's been calibrated. We've done the open circuit, short circuit and load calibration. We've got a VSWR of 1.24 at 149.92 megahertz. So about 1.2 at around about 150 megs, which is about what I'd expect from this antenna. Okay, we'll carry on with our experiment. We've shifted the antenna from that centre hole there, which is near the middle of this sheet, which is our counterpoise, our ground plane. And we're going to shift it progressively towards this edge here. And we just want to have a look at the VSWR. So I've got the en route through Sightmaster on hold at the moment, and we'll just have a look at how it's changed. Let's take it off hold. Okay. So it was 1.2 something or other. And it's now 1.33 at our centre frequency. So it is progressively getting worse. What we'll do now is we'll put this back on hold again and shift it right towards the edge of the sheet. Okay, as you can see, we're now right on the edge of the sheet. Well, I don't know what the result's going to be, but whatever we get here is going to be the sort of the typical VSWR type result when you start mounting aerials right on the edges of ground planes. Typical installations will be mudguards and boot lips and things like that. But anyway, we'll just try it and see what happens. Okay, well, we've had to change the scale a little bit. The VSWR now is, well, we've got 1 to 5 on this left hand side here, so we're more than 2.5. Got a VSWR more than 2.5, and at our frequency of interest, about 149.9 megs, we've got a VSWR of 3.38. Here's my counterpoise. I've just dropped it on the lawn. You can see the 3 holes in it. There's the centre hole, there's the intermediate hole, there's the edge hole. What we've done now is we've mounted our quarter wave whip straight into the middle of our sheet of core flute. So there is no ground plane here at all, or one which is immaterial. So I see this kind of thing on the job where we've got quarter wave whips like this mounted into fiberglass roofs, and in situations where there's very little ground plane at all, like mirror brackets and the like. Anyway, we'll go and have a look at the VSWR in this case. It'll probably be terrible, but let's go and have a look anyway. Okay, we're on hold, so we'll just run this thing Okay, so interestingly, at our frequency, it's 3.27. It's not that bad. But anyway, we've got a VSWR 1 to 5 up this left hand side and 140 to 160 across the bottom as before, and at our frequency of operation, it's the meters telling us it's 3.27. Now, a VSWR of 3.2, let's have a look in here and get an idea what a VSWR of 3.2 means in terms of loss, in terms of reduction in performance. Ooh, we're getting close to 25%, maybe a little bit more than 25%. 3.2, yeah, about 20%, 27% of the forward power is turned into reflected power. Now I'll put these charts, I'll splice them into the video so that you can do a screenshot. But that's a 25% reduction in performance, just by virtue of the fact you put up an antenna without an adequate ground plane. And if you don't check your VSWR, well, even if you do check it, if you don't correct it, you're on hiding to nothing. We've got a approximately 27% reduction in performance here, and you know, that's a little bit like paying a 27% tax, because there's no need to do it. If you get your antenna VSWR correct, you'll see an immediate improvement in performance and range, which no doubt your customers will be very happy about. So I guess the message here is beware of the bolter-oners. Beware of those people that are just bolting an aerial on the outside of your vehicle and not checking the VSWR. Because in all likelihood, unless they know exactly what they're doing, they could very easily be sacrificing at least a quarter of your performance.